This is part 3 of the Synthesis Basics tutorial in Super Collider. If we remember from part 2, we talked about envelopes and using the mix unit generator to mix different source oscillators. And of course, you can mix things like such as noise and other things as well. Today we're going to look at filtering and then also modulation. So we're going to try to cover quite a bit today in this tutorial. So let's look quickly at filtering. And remember, I was sort of employing this this convention, which you can do or you can do however you want, of just saving sort of on the variables and eating this variable, eating itself, and doing creating a new sound based on the old sound, you know. And that's kind of a interesting way to do that. So I'm going to go ahead and start in on a filter. And if I take the synth, in this case, it's a mix between the sawtooth wave and this pulse wave, each of which have an independent frequency control and an independent amplitude control. And each of those is being controlled here by these arguments. All right. So I take synth and I make it equal to itself. But now I'm going to filter this itself. So this mixture of these two waveforms, I'm going to use one out of the SC3 plugins called bmoog. Okay. And of course, you have to make it audio or if I open that, it tells us all the sort of arguments. And I think at this point, it's probably worth looking at the help file just to get the arguments. We're looking for an input signal to be processed. So whatever in is the signal that we filtered, a cutoff frequency, a Q or bandwidth, and then a mode, which is if it's 1 or less, or just less than 1, it's the low pass filter. If it's less than 2, it's a high pass filter. And if it's less than 3, it's a band pass filter. All right. So let's start with just a low pass. So in order to make it a low pass, we have to make sure our mode argument is less than 1. All right, and let's see. So our input signal will be itself synth. It's this mixed signal synth. Okay, and the frequency or the frequency of our filter, we'll put an argument in there, f freq, something like that. Okay, and we'll leave everything else the same except for mode. So, oh yeah, and I forgot, I was being very explicit about the argument. So I'm going to say in, so you know, and it's synth. And I'm going to say freq and f. Okay, and then mode. So the nice thing about naming arguments is you can skip the order. You don't have to go in the exact order as it's mapped out because you're labeling it. And I'm going to go less than 1. We'll just give it at 0 or whatever, 0.5, whatever, something like that. All right, we'll close that. So just to remember, under 1 is low pass, under 2 is high pass, and then under 3 is band pass. And then we need to add these arguments here, which is just simply the filter freq. And we'll give it a default value there, say of 1000 for now. Okay. And you notice since I ate synth, I don't have to change any of my arguments here. Synth is just carried on through to my out, and it's being multiplied by my envelope still. So if I go ahead and send that, has 4 tags. Okay, let's see. Oh, what did I do wrong? Okay, well, anyways, let's see what happens. Oh, right. Okay, I see this linear thing. Attack, time, release time. No, it's fine. Well, we'll see what happens. Okay, and then we'll send that there. And then we'll send this sort of backwards. And maybe make it a little bit longer. So if we have a release attack time of, say, 1.3. All right, we have to set our gate to 0. Okay, so you notice there it's a little bit more muffled. And we can just change that filter to even more muffled if we want. F. Change that to say 100 to see how that sounds. Again, close our gate, open it back up. Oh yeah, so it's quite muffled there. If you want to do a little brighter, 10,000 there. Oops. Okay, well there you go. You see how that works. And of course you can change your mode. So remember, because we don't have in the envelope, we don't have the done action to 2. It's still going, so we do have to free our synth if we're going to make a change. And let's change the mode here. And of course, you can make that an argument as well. So you can change the mode on the fly. But we'll make this under 3, so 2.5, something like that. And now that's a bandpass. And let's see if we send that there. And we don't want to make a bandpass that high. Let's make it something like 300 there. Okay. And how about 2000? Oops. Okay, so it's passing that band. Of course, you could change the Q if you wanted to. For example, let's see, it's in, it's freak, which I might as well put them in order. Q, and make it quite high if you want. Okay. Okay, and that's so that makes a narrow band, so it's more like a tone there. So, anyways, that's worth exploring there, filtering, and it's easy enough to just add a filter on top of what we had going on there. All right, now let's look a little bit at modulation. So this is where things can get even quite a bit more powerful in Super Collider. So instead of just having a sort of a set frequency, we can put that as a modulator. Okay, so I'm going to do it right here in place, and then I'm going to show you how to use a variable maybe to abstract it a little bit. So if we put, instead of a fixed frequency for the synth, if we sort of swept it, we can use a signal. And we just use a control rate signal, for example, a sine wave oscillator. And we're going to do control rate. And then we'll just have a frequency. Now remember, this is the frequency of sweep, how often it sweeps. And we'll go ahead and make that maybe 1 time a second. So you're not going to use audio rate frequencies because they're far too fast. Or you can do, frequency modulation that way. But that's not what we're doing today. Now, of course, sine oscillators oscillate between -1 and 1. So basically, if you think of the motion of your loudspeaker, and it's pushing the air, creating these pressure waves, -1 is essentially pulling all the way back, or maybe pushing all the way out, and 1 is pulling all the way back. So it oscillates between 1 and -1, moving your speaker cone. And that's what a sine oscillator does. And notice, sorry, I don't know if I mentioned that I use a control rate here because I'm modulating the frequency. I'm not actually making sound with it. All right. So you're going to have to change sort of the range of its oscillation. A frequency of -1 to 1 will be inaudible, 1 hertz. So we'll create a range, and you can do that quite easily here in Super Collider by doing dot range and then putting a range in these parentheses. So if I want to get a frequency range, if I want to sweep, say, from 100 hertz to, say, 5,000 hertz, something like that, and that's a sine wave every 1 second. So it's up from 100 back down to 5,000 every second. Okay, so let's give that a try. And we create the instance there. And then we send our, now we don't have a filter frequency anymore. Well, we do have it, but it's gone. So we send, okay, so you see that. And we can make its release, attack much longer. Reset the gate. Okay, and that's of course because we have this Q and this mode. So let's change the mode back to 0.5, so it's a low pass. And let's get rid of the Q argument. We just won't deal with that right now, but of course that's something you can deal with. We'll send that definition. Right. Low pass filter. Okay, so that's just a basic example of modulation. Take some modulator, and it could be a sawtooth wave, it could be any of these oscillators, a low frequency oscillator with the frequency down here, and then you're arranging it between these frequency range. Now, of course, you can make any of these things arguments. So instead of, we can say rate or LFO rate, something like that. Okay. And then we'll just make that an argument. We're not using this F frequency anymore. So we'll go LFO rate and make that a default of 1. So if we send that, we can change the LFO rate here to something very fast, for example, say 15. And let's see how that sounds. So it's a wobble texture. Okay. And of course, you can put these oscillators anywhere. So what I'm going to show you, one thing is I'm going to actually move that to a variable. So I'm going to call this LFO1. Okay. And if I put LFO1, 1 equals, and then just move that low frequency oscillator there to a variable, then it's just reusable all throughout my synth-def. So if I want to modulate this frequency by LFO1, I put that in there. For example, maybe I want to oscillate also the sawtooth frequency in there. So instead of sawfreak. So another good practice here sometimes when you're messing around with your code is to just comment out your code instead of deleting and changing things. That way you can still go back to your previous versions. And so instead of the sawfreak being that, I'm going to put in LFO1 here as well. Okay, and let's see how that sounds. Send that, create the instance, and then set the gate. Okay, and of course you can make an independent one as well. As many of these as you want. So LFO2, if I want to copy that, LFO1, and have another rate, LFO rate 2, make a copy of that as well, FO rate 2. And let's make that much slower, 0. Say 5, something like that. Okay, and then of course we have to change that to 2. So if we want our sawtooth wave frequency to be modulated by the slower one, we'll go ahead and do that and send that and send this. And okay, so you see you have the independent modulation there as well. Okay, so let me just show you a couple other things to do as well. So that's interesting. You can use things like sine os, and these are these sort of sweepy U-gens that will do sweep in the form of sine wave. Of course, you can use a sawtooth wave, which will ramp up and then quickly come down. Or like a pulse wave, which is on, off, that sort of thing. SuperGlider also has a number of sort of built-in, interesting sort of random generators as well. So for example, you can do, let's make another LFO3. Okay, and those actually do not really running at a frequent, well, I guess suppose it is. So we'll make a variable here, LFO3. Okay, and then we'll make it equal to this one called LF noise. So LF noise 0, okay, .kr. And basically, LF noise, as you may well know, noise is created by generating random numbers, random amplitudes, and as random as it is, sounds to our ears like noise. And if we use the LF noise U generator, you can also generate random values. So for example, and then again, it's the same thing. Frequency means how often it generates a new value. So let's put LFO rate 3. Okay. And then we will maybe make that same thing. Maybe once every 2 seconds it generates a new value. Okay, so instead of sweeping, it'll generate a random value. And you can get some interesting results doing this as well. And of course, you want to range this as well. So if you want to, for example, change my my pulse wave frequency. Oh, well, let's do something interesting. How about the pulse width? Okay, so we'll say And then we'll do something like that. We'll set that to an LFO. And so if we want our width, it's usually between 0 and 1. So even though I think noise already is generating a signal between 0 and 1, let's just be very explicit, just in case, so you understand that you can range it to something else. And then we'll range it to 0.0 and to 1.0. Okay. And then we'll put for the width, pulse width, we'll put LFO3. Okay. And then I'm going to change my envelope to here. We'll send that synth-def. Oops, some problems here. All right, LFO3 rate, because I didn't change that to 3. Great. And then we'll just change some of these attack things. So we'll have a normal attack, say 0.1, but we'll have a sustain this time with maybe like a 3, and then a release of, say, 0.1, something like that. Okay, so let's see how that sounds. Oh, it doesn't sound like anything. Oh, right, because I didn't create the instance. Sorry. So we do that. Okay, so you saw at the end there kind of the pulse width change a little bit. So it's changing that sound of the pulse wave. And sometimes you can get some interesting type of things by, for example, making that very quick, maybe that pulse. I don't know if this will do anything, but it's worth checking out. So LFO rate is basically saying it's going to generate, the LF noise is going to generate a random value at 55 times a second. So it's going to generate 55 random values between 0 and 1 every second. Okay, and then make that the actual pulse width. So it's going to be this very rapidly changing pulse width. It might not do anything. It might do something. Yeah, some kind of dirty random sound, or you can make it slower, however you want. Okay. Okay, so there you go. So basically, that's the idea for modulation and as well as filtering. So we added a filter here, and I show you some basic filter parameters and how to sort of eat your synth, and then create some arguments to go with that filter, and then just to modulate your filter and other aspects of your synth using these low frequency modulators, oscillators as well. And you can divide separate ones, and you can use the same one in multiple places, and you can use different ones in different places as well. Okay, so that'll finish up. And basically, I think we have pretty much everything we need to create quite a rich set of sounds using this idea of subtractive or modular synthesis.